In this video I'm going to show you one method of drawing the sketch for the legs, this part of the gear puller. If you go to the assignment on DayMap, which looks a little different on your screen than mine, when you click on this number it will take you to the PDF assignment, which looks like this. So the assignment has the front cover with some information about the showcase and evaluation. It has the performance standards. It's got the lesson by lesson outline so that we can get the tasks finished in time. An overall view, a parts list which we'll refer back to later, and some poorly dimensioned drawings. I've left them deliberately like that to challenge some of the students who have been doing CAD for a couple of years. At the end I've got some information about Circlipse, and that also is set up as an extension task for those students who did CAD when they were in Year 10. Now this drawing here is the information about the leg. So what I'm going to do, very roughly, I'm going to give you a bit of a guide as to how we're going to draw this on Inventor before we actually get to the Inventor screen. So what we're going to do is, first of all, draw a circle. So a complete circle rather than an arc. Now the radius of the circle is 12.5. So that means from the center of the circle anywhere out to the outside. Like the spokes on a wheel, on a bike, anywhere from the center, doesn't have to be just the horizontal or vertical lines, that distance is 12.5. So double 12.5 makes 25. So we're going to draw a diameter 25 millimeter circle, and we'll start it at 0, 0, 0 on the screen. We'll then draw a 6 millimeter circle inside that, and they will have the same centers. And the reason I've drawn that at 6 millimeters is because this here gives us the information about the 6 millimeter pin. And the pin, if we look back at the assembled view, the pin goes through here holding both of the legs onto the casting. It's not actually on this drawing, but that gives you the location of it, and that's why that diameter 6 and this diameter 6 are the same. Then what we're going to do is we're going to draw this 5 millimeter circle here. They've shown it as a construction circle, and we're going to draw a solid circle because that little part there, the little arc at the bottom, creates part of the leg. Now there's an assumption here because there isn't a dimension given to the location of the center of the circle to the bottom. So we are making an assumption. The assumption could be wrong, but we're assuming that the height of those are the same. So since this is 12.5, we know that distance there is 12.5. So I'm going to draw that roughly in line, and it's a diameter 5. Okay. So once we've done that, we're going to put a dimension on so that the dimension from the center of this circle to the dimension of this circle here is going to be 100. Okay. Then I'm going to draw two lines, one like this and one like this. Similar to what I've drawn on the screen, actually. They're going to be quite far away from the circles, not linked in with any automatic constraints. And then what I'm going to do is to teach you a specific skill about tangent. So for that purpose, we'll go to CAD now. I'll draw this little part of the sketch on the screen, and I'll show you the next step that I'm after. So we're going to go File, New. Now I deliberately don't pick these options. I want to make sure that I'm picking a millimeter part. So sometimes I think what students do is pick one of the drawings, and those little icons take you to an imperial part. So if we start that way, we're sure that we're on the right track. Now just maximize the view here so that we can, whoops, I went one too far. One more. And we're back to our normal ribbon where we can see everything. I'm going to start a sketch on this plane. So as I said, we're going to start at 0, 0, 0. We'll have a 25 millimeter circle, and inside of that we're going to have a 6 millimeter. Now by coincidence, but by no coincidence, I'm going to draw that deliberately, right click OK, so that the centers are not aligned. If we did it correctly, they would be in exactly the same centre, and that's called coincident in the middle there. They're concentric. All right, concentric meaning having the same centres. But I made a mistake. I click on this one, I click on this one, and this coincident constraint makes those two centres line up. So that's one little constraint tool that you will probably make good use of. Next, I'm going to draw my 5mm circle in line with the 0, 0, 0 line from here. Right, next right click OK. I'm going to dimension from the centre to the centre, drag it up, put the number in the centre, out of the way, click to locate it, and locate it at 100. Alright, now I'm going to draw two lines. I don't want that automatic constraint. See that little dotted line there? So move the mouse until you're just drawing a circle. Don't worry about those other constraints that are saying the sizes. They are fine. Right click OK to finish that line. Right click on the screen so I can then come up to the quick menu. And again, I'm starting that at 0 and I'm going to move it out here. I don't know a specific size. I'm just drawing a line at this point. So now to show you the tangent. The tangent constraint means that the line is perfectly touching the outside of the circle. So I need to select the circle and then the line and watch what happens and where it actually moves to. See that little icon that just showed up on the screen there? That is showing us that at that joint they are tangent. Same on the bottom here. If I, hold on, I might have missed the circle. Let's do that again. Select the circle and the line and they are now tangent. Okay. Now watch what happens when I make a tangent constraint between this circle and this line. Watch what happens to the circle. The circle moved because it wasn't locked in place. There is a tangent constraint, but if I cancel out of that, that little point there can move up and down because we haven't locked it in place. Right, and it won't be locked in place until we set a dimension. Now, we can set a dimension between that center point and that 0 and set it at 0. I'm just going to try something and see if I can do a horizontal constraint between those two. If I click up that center and that one, there's another way of doing that. So if I undo that a second, my other option was to go center button, a center point, and center point there. Something I didn't pick maybe. Sorry, cancel, try again. Center point of the circle, center point of that one. No, I'm doing something wrong. Let's try again. I might need to zoom in and very carefully pick the center point. I think it's picking the dimension and not the circle. See how it's already put the 100 in the spot there? Let's try from here. Here to here. That's better. Not sure why that was working. But my other option is to select and make the dimension 0. And by doing that, see how it's put that on the line? It's probably not the most technical way of doing that, whereas making the horizontal constraint is a better way of doing that. So if I select the center point of both of those circles, it moves it into that line. Okay, so next I'm going to just trim this little bit of the line and just at the same time make a point of showing you that that's where the line started. It didn't start right at that arc part there, which is why we've drawn this as a circle. Whilst I'm here, I'm also going to trim that part of the circle, and now we're left with that end part of the leg completed. So, for this part, I'm going to draw a circle, not anywhere in particular, not making any automatic constraints, and I'm going to make it 20 millimeters because on the drawing that we had before, the radius of this is 10. So double 10 makes it 20. So if I come back to that one, it's green, which means it isn't locked in anywhere. Now, in order to work out where to put this circle, if I go back to our drawing, the total length of the leg is 120 millimeters. So what I'm going to do is I'm going to dimension from the center point here along this line, and I'm going to make it 120, take away the 12.5, which is half of this circle here. Inventor won't allow me to select the outside of a circle and the end of this line here to dimension. It will only allow me to dimension to the center of a circle. So in order to get around that, I'm actually going to take the full length, take off this 12.5, and that will give me this bottom line here. So my line will be, let's assume my circle's here, my line will be out here somewhere, and we can put a construction line in and make the circle and that line tangent. And what that will mean is they'll touch each other, and that will be the correct length of the project. Let's give that a whirl and see how it goes. So dimension this line. Now I can type in the answer, which is 107, but I'm just going to show you that if I put in 120 and I take 12.5, an inventor will do that little bit of maths for us, and that's a nice thing to have. Then we're going to line, and then come over here to construction line. I'm going to draw a construction line right on the end of that, and I'm just going to make sure it's vertical. Doesn't matter what the length is. Come in and go tangent that circle to that line. Then I need to do the same at the bottom. Tangent that circle to that line, and that gives us the location. All right, a little bit of trimming to do later, but all I need to do now is to draw in a line which won't be a construction line, so I'll switch that off. I'm going to draw it here somewhere, no automatic constraints, so move it around patiently until you can just make it start. Draw a line up, and if it can, I don't think I want that 90 degrees. Hold on just a second, I'm just going to have a little look at something. Okay, so I thought I'd solved a problem that I was having before, but I have not, so let's keep going. Start a line and draw it somewhere out here. It makes no difference what the angle is because we're going to put in a dimension from there to there at 90. Oops, locate it first. And then I'm going to move that line over to this circle by using the tangent constraint. Because the circle is purple, it's not going to move, the line will move, which is what we want. So now what we've got is all the bases for the particular part of the leg. All we have to do is come in and trim all of these little extra bits of lines. You can trim that construction line, but you can leave it there. So it's of no consequence if you do leave it. It doesn't form part of the project because it is a construction line. All right, so let's have a little look. If I put a dimension on this from here to here, we are still not coming up with our 7 millimeters. So I really don't care too much about the 7. If you can get that to be 7, I'll be very impressed. All we have to do now is finish, and we extrude it. The size that we extrude it to, if we come back to here on the project, up to the parts list, and there's an error in here. There should be 4 of the leg, so part number 3, 1, 2, 3, 4 in order there. This is the number of, they call it off, number off, and this is the material, so the little headings are down the bottom here. There should be 4 legs. They're made out of bright mild steel, 25 by 7. So simply, all that means is you need to extrude this part here, the central part, to 7 millimeters, and that's the completion of the leg. That's one way of drawing it anyway.